Okay, Kobe, when have you heard of proportion before?
Oh, and when you're making cement.
Okay, yeah, like if you're making cement, right? You add cement plus water and I don't know, sand and stuff.
No,
Gravel.
sand, gravel, and something.
There you go.
Sand, gravel, and
Okay. Now, hold on. Okay. Yes, Elizabeth, you wanna? That's more of a ratio though than proportion, isn't it? Because that's like ratio of gravel, water, cement. Yeah, that was your only homework. Okay, so anybody? How about yes, Elizabeth?
Like when you do measurements, or like if your mom says like eat in proportion, like.
Right. Good. Good. Okay. Yeah. Making a cake, sure. So, for example, do you always follow? Did you want to add something? Oh, you were gonna say that making. Okay, so let me ask you this then, Madeline. If you're making a cake and so forth, you know, if you look at, if you want to make twice as much as what the recipe says, what do? You multiply all the ingredients by 2. Kind of same idea. Okay, so it turns out proportion is an equation actually. And it's an equation that says 2 ratios are equal. Okay? So it's an equation that states that 2 ratios are equal is called proportion. Okay? So for example, if you're baking a cake, whatever the recipe says, right? If you want to make twice as much, you know, you multiply that all by 2, and you would have, but the ratio would remain the same. It's just, you know, the other one has twice as much ingredient, and you would have twice as much food, right? Okay, that's the idea. So, write this down. And so let me give you a very simple proportion. Does anybody know? Okay, let's say I have a ratio 2 to 3. Can somebody give me another ratio that is 2 to 3? Yes.
4 to 6.
4 to 6 is another one. So if I equate those 2 together, guess what we have here? It's a proportion. A lot of times, actually, you want to write it as a fraction this way. Okay.
That's all it is.
Well, not all, but that's the basic idea. And using this basic idea, we're gonna kind of go, you know, do some problems. And the way we read this proportion, does anybody know how to read this proportion? Not like 2 over 3 equals to 4 6. Okay, that's reading as a, you know, some fraction. But then, as a proportion, you say, yeah.
2 over 3 is proportionate to 4 or 6.
You can say it that way, or I'm looking for this one. 2 is to 3 as 4 is to 6. I don't know if you've heard of this before. So the way we read this is 2 is to 3 as 4 is to 6. And so you can see 2 is to 3, that's the ratio, equals to 4 to 6, okay? And I bet a lot of you have already seen this before. If I have this proportion, Anais, A over B equals to C over D, is there a way to rewrite this little bit, rewrite this equation? This is an equation after all, right? In a way so that we don't have any denominators. Is there a way to rewrite this? So that we don't have any denominators, but the equation is still equivalent. Equations will be still equivalent, but you could rewrite this equation or this proportion without any denominators. Talene. AD equals to CD is correct. Have you guys seen this before? No? Okay. They basically multiply A times D equals to C times D. You haven't seen this? That's fine. When have you seen this, Anais? What do we call this, by the way?
I just remember seeing it like I had this one problem when I had to figure out.
Okay.
I had to figure out C.
Right.
So you multiply A and D and divide by.
Yeah, and we sort of, yeah.
Multiplication property of equality.
Actually, that's what they're using. You said multiplication property of equality. How do they get from here to here? You're right. How do they actually use multiplication property of equality? What is that called, by the way? I mean, what is that, by the way? What is it's called multiplication property of equality? What is it? Yes, Cameron? Okay, good. So another name for this is called cross multiplying. But Sarah is right. This is just a shortcut, but we are using multiplication property of equality. By the way, what is that? Do you guys remember this? Yes.
It means that if you multiply both sides of the equation by the same number, it stays equal.
That's right. It says that if you have an equation, you can multiply both sides of an equation by the same number. It'll stay equivalent, right? Guess what we multiply both sides by? So that we get this shortcut. AD equals to BC. Anybody see what we multiply both sides of this equation? A over B equals to C over D? Someone I haven't picked? Alvin? CD? No. If you multiply both sides by CD, you don't get AD equals to BC. Yes, Caroline? Reciprocal of what? A over B, which is B over A. If you were to multiply both sides by B over A, none of the denominators cancel out, do you? Do they? Derek? BD is correct. We're basically multiplying both sides by, this is the reason why. Why do we get this? We're multiplying both sides by D, BD, which is the LCD in this case. The product of the denominators, right? If you multiply both sides by the product of the denominators, look, if I multiply BD on the left side, B's cancel out. If I multiply the right side by BD, D's cancel out. So you get A times D equals to C times D. Right? So this is known as cross multiplying, but really, I don't like that shortcut, because a lot of times people just kind of blindly do it and get things wrong, and they do this when you're not supposed to, so people get it wrong. So I would like you to understand this as the multiplication property of equality, right? You're multiplying both sides by basically the LCD in this case, the product of the denominators. Okay? Does that make sense? Do you guys see that? As you can see, when I do this, all the denominators go away, right? Yes, question?
Wait, so it can work even if there's different variables involved?
Well, in this case, they're all 4 variables, right? But as I do an example, it'll make more sense. So, here's an example where you may see something like this on your homework, okay? Good question. Okay, so may I move on then? All right. So, sure, that's a good question. Here's a question that you may see on the test or on your homework. Something like this, right? This time there's only one variable. So I have x over 3 equals to 15 over 12. Okay? I mean, 5 over 12, my bad. 5 over 12. Now, knowing what we just learned, what can we do to solve for x? In other words, let's just get rid of all the denominators. After all, it's an equation, right? But we just learned a nice way to get rid of all the denominators when it's in this equation, like when a fraction equals to another fraction, which is called what? What do we call when you have a fraction equal to another fraction? It's called a what? Ratio. No, it's not ratio. These are ratios. Ratio equals proportion. It's correct. So if we have this proportion, what can we do to get rid of all these denominators? We can multiply both sides by, yes sir? 36, which is really 3 times 12. I'm not going to write 36. I'm going to write 3 times 12. Does anybody see why? I want to just write, yes. Yeah, so I could just cross cancel easily, right? Because you know that each of these factors are in there. You see how 3's cancel out and then the 12's cancel out? So what do we get? We get, what do we get? Yeah? Oh, that's the answer, but what's the next step? Yes, Madeline? 15 equals to 12x. Yes. Got 12 equals to 12x equals 15. And then, of course, you divide both sides by 12 and you get 5 over what? 4. Any question? Elizabeth, what's your question?
Can't you just multiply x over 3 by 4?
Yeah, you're like, wait a minute. Why, Mr. Huang, why are you doing all this work? We know how to solve this simple equation. This is x divided by 3, right? So how do you undo division? You just simply multiply both sides by 3. And do you get the same answer? Yes, you get it. Right? Why am I showing you this way, by the way? But we could actually do it this way, even though it took a little longer than the normal way of solving. Yes. Why do you think I showed you? Yeah, Laura?
Problems where it's not going to work.
Yeah, there are problems where it will not work this simply. But if you could do it simply, that's fine. But what about this? That's why I have example 1b. I have 3 over x equals to 12 over 5. Okay. In this case, could we get x by itself right away with just one step as before? Why not? Can we just divide both sides by 3? Because it's 3 over x. So why not divide both sides by 3 and get x on the left side? Anais, do we get x? What do we get if you just divide both sides by 3? Shra? What would this be if I were to just divide both sides by 3? Do I get x, Shra? We're looking at, what do we get? We're looking at this, right? 3 over x equals to 12 over 5.
Oh, we divide by 3?
Yeah, why don't we just divide by 3 and get x by itself, right? Is that what we... No, that's not what you do because you don't get x. Aaron, what do we get? It becomes 1 over x. Okay, guys, pay attention because I see a lot of you like. Okay. So that's why when you have something like this, what can we do? Multiply both sides by then? LCD, yeah, this time LCD, which is 5 times x. If I do that, then the x cancel out, 5 cancels out. It gets really nice. It becomes 3 times 5 equals to 12x. Guess what? Divide both sides by 12, and we get, again, 5/4. Does that make sense? So that's the reason why I showed you. You're right, Laura. Yeah, there are times where you just want to, sometimes it's easy. Yeah, you just do it in one step. If x is on the numerator, but if x is in the denominator, okay, we want to multiply both sides by the LCD and so forth. Bring it up. Because we don't like to have x on the denominator. Okay, it gets hard. So every time you have some variables in the denominators, or if you have like a lot of fractions, right, you want to get rid of all the fractions. Okay, if you have equations, there's an easy way to do this, which is doing it this way. Multiply both sides by the product of the denominators, or the LCD. Yes? Yes? Like as usual, right? Isn't that what we've been doing? Yeah. Unless I say otherwise, yeah, I like improper. Okay? Alright, so knowing what we know from example 1, here's example 2. Nothing that, it's not that much different than example 1, except now I have binomial on the numerator. Do you think you know how to solve this one now? Okay, go ahead, everybody try. And again, this would not be just one sort of step problem, right? Because you have x in both sides of the numerator. Go ahead, everybody try, see what you could do. Get rid of the denominators, really, okay? All right. Okay, I think a lot of you already have talked to your group members and so forth. Okay, how about, let me call on Andrew. Andrew, what do I do first?
You have to multiply all the denominators.
What do you mean by that?
Like 5 times 2 over 1 times 3x plus 1 over 5.
No. What do you mean? We want to get rid of the denominators, right? I just didn't hear you correctly. My bad. Okay, tell me what to write.
Yeah, 5 times 2 over 1 times 3x plus 1 over 5.
Oh, okay. Sorry. Then you cancel things out. Then what's my next step, Andrew?
You would have 2 times 3x plus 1 over 1
Mm-hmm.
equals 5x over 1.
Thank you. Matthew, what do I do next? How do I solve for x here, Matthew? Okay, you have x on the left side and the x on the right side, but the x on the left side is in the parentheses, so let's get rid of it. Yeah, tell me what to write. That's correct. Then, what should we do? Should I get rid of the 6x or 5x? How many people say get rid of the 6x? Raise your hand. How many people say get rid of the 5x? Okay, it doesn't matter. Does it matter, really? No, it doesn't matter. So let me get rid of 6x first. Then when you get rid of 6x, don't you get negative 2 as the answer? Because you get 2 on the left side. You get 5x minus 6 is negative 1, right? X. What if you got rid of the 5x? Okay, on the left side, if I get rid of the 5x from both sides, I get what? Omen. X plus 2 equals 2? 0 is correct. Could I just leave it as x plus 2? Because it's 0. Could I forget about that 0? No, then you don't have an equation, right? X plus 2, it just becomes an expression. I don't know. Some people just leave it like x plus 2 and then they say the answer is 2 or something. That's wrong, okay? X plus 2 equals to 0. You need to have that 0 there, right? Right? To keep an equation, right? You need both sides. So of course, then for both, it doesn't matter which way you do it. You get x equals to negative 2. Of course, as long as you do them correctly. Do you guys get the idea? Okay, so we're basically getting rid of all these fractions so that we could get an equation where we could solve easily. Okay, that's the basic idea. Right, and what property are we using to do that? Multiplication property of? Thank you, very good. All right, let's look at the next example. Here's example 3, very similar to one that we just did. Go ahead, everybody go ahead and try. People at random. Okay, how about Audrey? What did you do first?
Multiply 12 times 5 over 1.
Good. Multiply both sides by what?
12 times 5
12 times 5 over 1 is correct. And once you do that, that's a key step, right? Once you do that, bless you. Then we cancel things out. Lindsay, what do we get on the left side? X minus 5 times 5 equals to? Yep. Of course, those two binomials are in parentheses, right? All right, Andrew? Okay. So then we get this. Kristen, then what do we get after this?
You get 5x minus 25 equals 12x plus 25.
Good. Now, Savannah, what should I do next? Yeah, let's get rid of 5x. So, you get positive x. So when you do that, you get? Good, and then you subtract 24. How many people got x equals to negative 7? Raise your hand. Pretty straightforward. Any questions? Good. All right, let's get to the next. So we got 2 other problems, and these 2 problems are your favorite. Guess what we have? That's right, your word problems. Just like you have for your homework tonight. So write this down. Yeah, okay. Yes, write it down. An investment of $1,200 paid interest of $102. How much interest was $1,600 invested at the same rate for the same amount of the time pay? Okay, so write it down. Yeah, so you got $1,200. If you invest that much, you get $102 back. How much interest would $1,600 invested at the same rate for the same amount of time pay? Okay. All right. So, Christine, reading this problem, can you explain to me what's going on? Like, what is this problem saying? Like, what are they talking about?
They are saying that an investment of $1,200
Uh-huh.
interest of $102.
Uh-huh.
They're asking for how much interest would $1,600 invested at the same rate for the same amount of time paid.
Exactly. So if you invested, you kind of read the whole thing, but basically, if you invested $12,000, how much do you get back? 102. Okay. If you invest more money, like $1,600, how much do you get back? X. That's what we don't know, right? By the way, do you expect the answer to come out to be more than $102 or less than? It's got to be more. You're investing more because they said it's for same amount of time and same amount of rate, right? So, what is our unknown here? Matthew? What's my unknown? Pay attention, please. Right? What does the X represent?
How much interest is made from $1,600?
That's exactly right. And I like how you were specific enough. Could I just say how much interest you made? Would that be specific enough? No, Kyle, why not?
Because it's the interest, X is the interest of the 16,000, not interest of just the
Exactly, not interest for the 1,200. Does that make sense, guys? Now, what is our topic today? Again, proportions. Now, in order to get proportion, do you think we're gonna need some proportion here?
Yes.
In order to get proportion, what do you need? You need you need ratios. How many? 2 of them. So and then they're gonna have to equal to each other, right? Does anybody see any ratio in this problem? Alvin?
$1,200 over $102 equals $1,600 over X.
Yeah, you actually gave me the equation. So the 2 ratios that Alvin saw was this. For $1,200, right? You make $102, right? And for $1,600, it makes X amount because that's what we want to find. And Alvin says, well, if that's true, right? They must have the same ratio, right? These ratio must be same, right? So they have the same. So you could come up with a proportion. And some of you are asking, well, which one do I write? Do I write the one on the left where you have the 12,000 and the 16 on the top, or does it matter?
No, it does not.
It does not matter.
Yeah.
Which one's better?
The
Well, it doesn't matter. No, really, it doesn't matter. Whichever way. It doesn't matter.
Yeah.
Well, yes, it does. Okay, that's a very good point. If you're going to put down 1,200 on the numerator, do you think you need 1,600 on the numerator? If you're going to put down 1,200 on the denominator, do you think you're going to need 1,600 on the denominator? Yeah, that matters. What I'm saying is, what goes up on the numerator? is it the investment or the interest? Does it matter? No, as long as you're consistent, right? It doesn't matter. That's what I meant. Yeah, of course it will matter if you switch that around, right? Okay, so go ahead, everybody solve for x. Either one on the left or right equation will be fine. Okay, go ahead. I'll give you some time. Oh, you already finished? Okay, check it with your neighbors. I mean, with your group, not neighbors, group. Check with your group. Go ahead, guys. No, don't talk to the other people within your group. Okay. Okay, so I started off with the one on the right, just because the x was in the numerator, but it doesn't really matter. So I multiply both sides by 1600 times 1200 on the left, 1600 times 1600, I mean. Oh, no. 1200 times 1600, yeah. And so when they cancel out, what do I get, guys? So on the left, what do I get? On the left side, I get, yeah, I get 1600. Do I need to multiply this right now? I saw some of you getting out your calculator. No, you don't want to use a calculator because you don't get to use it on the test. So just write this down. Don't multiply this yet. You'll see why you don't want to multiply this yet, guys. Okay, equals to, guys, I need you to, Aaron? Okay, I know you guys working on this. Can you, okay, so hold on. On the right side, we get, just watch this one out, and then 1200x. Now, the reason why I didn't multiply is because I knew that I had to divide both sides by 1200 both sides, right? And things will cancel out. So I don't want to I don't want to do all this work right now, right? Because things will cancel out. So divide both sides by 1200. And of course, you get x on the right side. Now, okay, let's just do the, okay, what is 1600 over 1200? 16 over 12, right? You can divide top and bottom by 10, right? Times 102 over, oh, not over 120. 102 over 1. 12. I had 12 already here. 1, right? Now, does anything go into 12 and 102? Well, 16 and 12. What goes into 16 and 12? 4. So 4 goes into 16 4 times. What about 12? 3. By the way, does 3 go into 102? It would be nice if it does. It does. How do we know we could add all the digits, right? 1 plus 0 plus 2 is 3. How many times does 3 go into 102? 44? 44, really? 44. 34 times, okay? Okay, what? Okay, so, don't we get x equals to 4 times 34, which is, how many people got? 136. Now, more importantly, how many people got, listen, is that the answer? Is that how we write the answer? Yes, what should we write? Shh, hold on. What should we write?
With an investment of $1,600, you would make an interest of $136.
Excellent. Did you hear this? Okay, Cameron? What did she say? What did Sophia say? Okay, you weren't paying attention, were you? Okay, so Sophia, can you repeat your answer so that Cameron and all the rest of the group could hear? Listen now. Shh.
With an investment of $1,600, you would make an interest of $136.
There you go. And she was really specific. I wasn't that specific, but that was great. I just wrote down he would make 136 for investing. I didn't investing. 1600. Okay? But you get the idea. Any question? Guys, do you think you could do something like this by yourself now? Okay, let me give you the next question. Everybody try. This is the last one, okay? A typist types an essay of 1,260 words in 15 minutes. At that same rate, when it says at that rate, I mean at that same rate, how long would it take to type an essay of 2,100 words? By the way, do you expect to be more than 15 or less than? More. That's right. Okay, because you're typing more. Go ahead, everybody try now. Okay. It's very similar to the one we just did. Go ahead. 15 minutes is correct, yes. All right, so, Shrek, I want you to sit on the other one. No one, yeah, not that one. Yeah. Okay, Emily, what is our, Emily, what's our, not equation, what's our unknown, first of all?
I wrote let x equal minutes it takes to type 2,100.
Good, I like how you're being specific. Is it good enough to just write down how long it takes to type? No, there are two cases, right? So you don't want to be just, okay, Harrison, then what's our, we need two ratios, don't we, to make it into a proportion. Do you see any ratios here?
Yeah, yeah, 15 minutes, yeah. And
Yeah. What about 15 minutes? What goes along with 15 minutes? I thought we talked just with the
yeah, 15 over 1,060. 260.
right. So this person can type 260 words in 15 minutes, correct? So that's actually it turns out that's not a ratio. We cheated a little bit here. That's actually a rate because they don't have the same unit, do they? It's okay. It'll still work out. Don't worry. Okay. What about then for 2,100 words? How many minutes does it take? We don't know. That's x. So those are the two. So we need two rates. Well, this time two ratios. So we need two ratios, and that's what we have. Who could tell me the equation? How about, who haven't I called today? Judy, tell me the equation.
15 over 1260 plus x over 20.
You're exactly right. I just do it the other way. It doesn't matter, does it? Okay? And when you solve, for me, I multiply both sides by the LCD, which is 15x. How many people got, you cancel things, everything out? How many people got 25? Yeah. Yes? No? Okay, if you didn't, go ahead and check it with your groups. The answer is 25. Here's the work. Go ahead. And did you all write this as a sentence? Okay, it takes 25 minutes to type 2,010 words. Okay, go ahead and fix it now. Go ahead, guys.